Today, April 12, is World Aviation and Cosmonautics Day. Petro Trokimchik, Associate Professor of the Department of Theoretical and Mathematical Physics of the East European National University named after Lesia Ukrainka, told concurrent interesting facts about space. 1. What is space? Space is the same as the universe. The universe is the world that surrounds us. This is what we see. 2. Is space synonymous with the word universe? Universe is a Ukrainian word. Cosmos is Latin. Yes, these are synonyms. 3. How big is the universe? There is a limit to the universe. The boundaries of the universe are 3.5 megaparsecs or 12.5 billion light years, which corresponds to a lifetime of 12.5 billion years. 4. How old is the universe? This coincides with the time of the existence of the universe after the Big Bang. That is, these are the same 12.5 billion years. 5. What will happen if I am thrown into outer space now? Nothing will happen if you are thrown from the spaceship. You will simply turn into ice. It is also necessary to take into account what is still open space. If, let's say, you are thrown out where the intergalactic density is much lower than the intergalactic density, then you will simply turn into a piece of ice. If we talk about open space, where the density of the substance that is near a star is also greater, as between the stars, then it will be the same, with the difference that you will turn into a new asteroid if you fall into the zone of gravitational influence of the corresponding star or planet. So everything here is relative. 6. Why does the Earth spin? Everything is very simple. The Sun is the remnants of the explosion of a supernova. When the star ceases to be stationary, there the energy begins to be absorbed, not released. The core is compressed and the shell goes for a walk. That is, it breaks away from the core. A protoplanetary cloud is formed from the shell. So when it starts spinning, it usually has the rotational motion of this cloud. Where is the highest speed? Where some particles can escape from this center. A disk spins along the wall of the equator. Further, inhomogeneities begin to appear again, which absorb matter around them. The Earth, like all the planets of the solar system, rotates in one direction. 7. Why do all the planets of the solar system rotate in the same direction? All the planets of the solar system spin like a spindle. In the early stage of the formation of the Sun, which arose from the ashes of stars, according to the condensation theory of James Hopwood Jeans, condensation occurred. From it arose the proto-Sun, which began to attract other parts of this ash to itself. A spherically symmetrical object was formed, which rotated around a certain axis of rotation. Particles have the highest speed in the equatorial plane. Because of that, they can best detach from the central body. That is why something similar to the rings of Saturn formed in the equatorial plane at the initial stage from the protoplanetary cloud. Again, thanks to the instabilities of Jeans, protoplanets arose. They rotate in the same direction as the proto-ring. The direction of rotation around its axis is also related to the rotation around the Sun. For example, Earth and Mars are lucky. They have approximately the same rotation period. It is about 24 hours around the axis. Giant planets have 11 to 16 days each. These are their rotation periods. That is, here everything depends on how the solar system was formed. 8. Are there any sounds in space? Seeing what you understand by the word sounds. Of course, there are some, perhaps, sounds and ultrasounds, but of extremely low intensity. And there are fluctuations of other frequencies. If you are looking for extraterrestrial civilizations, then, as a rule, you are looking for them in the radio range, because it is in this range that the main means of transmitting information on Earth work. That is, they are looking for colleagues who are similar in mind to the Earth's biosphere. 9. What are black holes? The concept of a massive body whose gravitational attraction is so great that the velocity required to overcome this attraction, the second cosmic velocity, is equal to or greater than the speed of light, was first formulated in 1784 by John Michell in his letter to the Royal Society of Great Britain. Michell called such objects dark stars. In 1795, P.S. Laplace called such objects black holes. In 1930, the Indian Subramanian Chandrasekhar came up with a formula to estimate the size of such an object. According to this method, he estimated the size of the white dwarf. Later, Volkov and Oppenheimer used this method to estimate the size of a neutron star, which they considered to be a black hole. Currently, black holes are considered objects that have a density greater than the density of neutron stars. There are local black holes, Zeldovich-Chunyov theory of 1967, that can attract objects at short distances. Well, for example, with the help of such a black star, you can press cars at the dump. And there are massive black holes. Their nature is unknown there. That is, anything larger than the density of a neutron star is called a black hole. According to one hypothesis, it is in the middle of our galaxy. Such a black hole has a rotation period of 2 to 3 seconds and a mass equal to 1 million masses of the Sun. Imagine such an object, which has a size of several centimeters and rotates at high speed around an axis. 10. What will happen if I fall into a black hole? If you fall into a black hole, nothing will be left of you. You will not physically understand or think anything there, because you will not even turn into atoms or nuclei there, and something much more compact. 11. What is dark matter? This can be explained using Einstein's equation. From this point of view, the equation can be considered a non-homogeneous functional expansion of the Mitchell equation. This is essentially an energy balance equation. The essence of this equation is that the kinetic energy momentum tensor is equal to the potential energy Einstein's tensor. To explain the stability of our universe, there is not enough data from well-known branches of physics. That is why the potential energy, the source of which is not reliably known to us, was called dark mass, due to the equivalence of mass and energy according to Einstein. The same part of kinetic energy, the source of which we do not reliably know, was called dark energy. 2. Are people alone in the universe, or are there other living beings? It is possible that we are not alone. 15 years ago, Italian scientists found a meteorite, and it has a crystalline structure in which the genetic information of living objects was encoded. That is, scientists refuted the idea that living organisms have different symmetry from inorganic nature. The symmetry of the 5th and 7th orders describes quasicrystals. There are theories about the possibility of the existence of other planets. In our galaxy, there can be from 3 to 50,000 planets where there can be life, if you make an estimate according to Drake. There are, of course, many more planets. Every star has planets. There are few single stars in our galaxy. Most stars are multiples, that is, they have 2 to 3 components. In addition, planets can have red and brown dwarfs. There is a large radio telescope in Puerto Rico that is picking up radio signals in the universe in connection with the search for brothers of mind. Until recently, as far as I know, nothing has been caught. 13. Is it possible to resettle people in space? There are 3 such resettlement projects. 1. You can build large spaceships according to O'Neill's design. It is a cylinder with a base in the form of a regular polyhedron that rotates around an axis. The base of the cylinder is directed towards the Sun. Sectors across one are transparent agricultural land and dark industrial and residential areas. The cylinder rotates around its axis at such a speed that the centrifugal force is equal to the force of the Earth's gravity. Drake's project hierarchical model. Hierarchical construction of octahedra. The ratio of the diameter of the base of the rod to the length is 1 to 100. An octahedron is built from the rods. From 100 octahedra, a new rod and so on. Such a cellular structure does not have a clearly defined center, therefore there is practically no internal gravitational compression. Therefore, it is twisted around the axis. Drake's project requires much less building material, and his hive will be more stable from a mechanical point of view. In the Drake project, 320 million